All right, well, welcome back. Let's take a look at our latest review. This is for modules 11, 12, and the beginning part of 13. So we'll kick it off. Here we go. We're going to start by looking at a little bit of stuff about quadrilaterals. And you want to remember that a quadrilateral is always a polygon whose sum is 360 degrees. So if we start with this problem and I guess we could start by finding out what all these things add up to. I got a 109 and a 96 and a 70. So those angles all add up to 275. So somehow I would have x plus 275 would have to be a total of 360. So if I took my 360 and subtracted 275, it looks like my remaining angle would need to be 85 degrees. Okay, not too bad. Okay, next one over. Now we tried to make this one a little teeny bit harder, and that is because we have some exterior angles. That's what these are called. But we should know that these angles right here form a linear pair. So somehow, whatever these two angles are, they have to add up to 180. So the first thing I'm going to do is start with my 180 minus that 112, and I'd find out that this interior angle now is 68. And in the same way, if we take 180 and subtract this 122 here, I'd find out that that angle is 58. And now we have kind of a very similar problem to the last one. I'm going to go ahead and take the 58 and the 68 that I just found and add it to that 132, and I have a total of 258. And so somehow x plus 258 again has to be equal to 360. So let's take 360 minus 258, and we're looking at 102. Okay, that's 102 degrees. Sorry about the glare. And we're good to go. So remember, anytime you have a quadrilateral, we were talking 1, 2, 3, 4 sides. Those 4 sides have to have a sum of 360 degrees, or at least those angles do, excuse me. Now, next little piece. Little fact known about parallelograms is that the diagonals always bisect each other. So that's kind of an important feature. And that is going to go in like this. So I know that V plus 12 has going to be equal to 5V. Now, if that's true, then I could subtract V from both sides, and I would find that 4V is 12, or V, in fact, is 3. So I know the value of V, but a lot of times we want you to plug that back in. And if V is 3, then 5 times V is 15. And if V is 3, V plus 12 is also 15. And it asks me for the length from A to P, which of course is 15. Now, I feel like we've got a little something missing in this next one, so I'm going to have to skip over it because it told me that this is 4W minus 2, but I don't have the other side, so we're going to have to make a little change in this thing. And so when you get it, we're going to go ahead and take whatever DC is, and we're going to set it equal to AB. So we're going to take 4W minus 2 and set it equal to whatever AB is, and we'll have that for you in class. But evidently my copy does not have that right now. Okay, so moving along. If we have a parallelogram here, not only do we have the fact that the diagonals bisect each other like that happen, and that opposite sides are equal, notice that we have to figure out whatever AB is, but we also know that the opposite angles are also equal to each other. And you'll notice it kind of helps because you'll notice this angle looks a little bit obtuse and that one looks the same. It's actually helpful that they actually look like what's supposed to happen. So I guess I'm going to go ahead and just do a little bit of algebra, and I would have 4m plus 4 equals 24. I'll subtract 4 from both sides and get 4m equals 20, and a little division found that m is 5. Now, we frequently will do this and just kind of stop right there, but the reality is I'd like you to go a little bit further. And if you plugged in m equals 5, then 7 times 5 plus 4 is 35, plus 4 is 39. Measure of angle I is 39 degrees. So I know that this angle is 39, and that should tell me that K should be 39, but we can double check. 3 times 5 is 15. That works. Now, what I wanted to ask on this little review is what about L itself? Well, a nice little fact is not only are the adjacent angles equal, these opposite angles are equal, the adjacent angles add up to 180. So if I took 180 and I subtracted 39, hopefully you can see that okay with the glare, this missing angle right here would be 141 degrees. That's a question that I would like to put on your test. And my last question for this page, other than the one that I could not answer, is that if you have a rhombus, by definition, all of the sides have to be the same. So I know that 4x plus 17 would have to be the same as 8x minus 3. And so we can do a little movement of variables around. Let's go ahead and add 3 to both sides. And I got that x is 5. So that's awesome. I got x equals 5, but you're going to notice that it didn't ask for that. It asked for the length of j to k. And 4 times 5 is 20, and 20 plus 17 is 37. So jk is 37. And jk is 37. That means kl is 37. It means all of these guys are 37. Everybody's 37 because it's a rhombus. And last but not least, if something is a rhombus, then it is also a parallelogram. And that means these two angles right here have to add up to 180 degrees. Please do not fall into the trap that people fall into and immediately just set things equal. That's not true. In a parallelogram, any two adjacent angles add up to 180. So I'm going to put those together and make that 103. And so let's see, we'll take 180, let's subtract the 103 from both sides. Let's see, what is 180 minus 103? I should have that, huh? 180 minus 103, I'm thinking it's 77, but I just wanted to make sure. So we got 7y is 77, so y is 11. But interestingly enough, I didn't need to do all that. It asked me for the measure of angle J, and I should have been able to just look at it and say, if that's 108, then this angle has to be 72 because that's how those would add up to 180. So I could say that y is 11, but I could have jumped straight to the fact that the measure of angle J is 72 by just knowing that those two angles have to add up to 180. I didn't even need to find the value of that variable. All right, that's the end of page 1. Sorry about the missing question there. I guess you'll have to see in class what that one was. Okay, bye-bye. See you later.